Assalamu alaikum, ya'atikum al-afiyah. First of all, I'd like to say thank you to Professor Brian for an excellent presentation, as well as I'd like to tell him that I do have a student here, and it's a very memorable student that once gave me his bank card instead of his student ID in a proctoring out of sheer fear from the exam. And he's graduated and become a member of AOU, and I've told him to always relax in exam times, so we do have students. I also referenced Professor Brian about oil, and he said that we should test oil within the markets and how oil is contributed and how we may understand oil. So first I'd like to say I am Dr. Azzam Alroomi, and it is a privilege to be here, and I thank you for... Sorry? Thank you for that. And I thank you for your attendance. It's a complete pleasure. So here, when I talk about predict or understand, the issue is when we want to quantify volatility spillovers, either unidirectional or bidirectional, how can we understand the effects of one parameter to another parameter? Should we build on statistical techniques? And this is a paper that I have. Should we build on statistical techniques, or should we go back, I'll do my best, or should we go back to artificial intelligence? So what I have done, I have compared the HAR model, which is the heterogeneous autoregressive model, with the LSTM model, which is long short-term memory model. I wish I can have the same thing, because that model forgets what is not significant. So if something is not significant and does not impact the outcome of the volatility spillover from one parameter to the other parameter, the actual model forgets it. How does it forget it? It forgets it from terms of 0 to 1. So the closer to 1 it is, it remembers it. So it has more significance, more iterations, better within the network. If it's closer to 0, it forgets it, doesn't even exist, and removes it from the equation. So these are the acronyms for the introductions and the presentation. I will try and do my best to move forward as quickly as possible. I don't know how I'm going to do it in 2 minutes, but I'll do my best. So we're doing interconnectedness. What I mean by interconnectedness, I mean how are the countries connected? I'll give you a data for you to think of. So from the 1950s till today, how much do you think value of trade has increased? Value, not volume. 38,200. 38,200, according to the World Trade Organization. 38,000%. 382-fold the value. And the volume, 43%. So 4,300%. That is an increase in interconnectedness between one country and another country, between one government and another government. So how am I trying to understand this interconnectedness? How am I trying to understand this spillover? And if McKinsey looks into something, if McKinsey looks into a market of how interconnected it is, and how the commodity market works in the US or any other countries, how oil affects other countries, how changes in volatility affects other countries. Because like many other professors, we have always tried to predict and understand the uncertainty within markets, within the financial market. But that doesn't usually work. I've tried it, and I got a paper accepted 3 days ago that contradicts this paper, that tries to understand the uncertainty in financial markets. So I've become to fathoming that it is better, instead of understanding uncertainty and prediction, it is better to have a reactive response. So be reactive to what happens. So if a spillover happened from one market to another market, we can react. We can have a parameter that controls that. And I do all of this using artificial intelligence. So I try and compare machine learning against statistical techniques. So we move forward. I'll try and move as forward as I can. Yeah. So spillover and prediction of market crisis. Here's the first model. So the first model tries to predict and understand as a statistical space model that it is not a large language thinking model. It is a normal statistical technique model. It's an econometric model. So you have sigma, and M is monthly, goes into the beta coefficient, and beta 1, 2, 3, T minus 4 is the data, the training data. So T minus 4 is the weekly data, so 5 days before. And T minus 21 is 21 days if you do the months, so on and so forth. And then at the end, we have the error term. So you compute for the errors. This is the normal thinking, normal idea of mathematics in the recent world. But is the new mathematics keeping up with the data that we can do it? Can we keep up with the new artificial intelligence data, complexity of data? Yes and no. So we move on to the second model. The second model takes account into engineering, computer science, artificial intelligence, mathematics, so on and so forth. So here we have the long short-term memory where we try and compute 5 different stages. Stage number 1 is the FT stage. Here is the sigmoid activation function. It is not sigma as well. So the first state tries to remember or forget. I'll move on to this. I'll come to this and show you exactly what it is. So tries to remember or forget if the input is not worth changes within the market. The iteration IT is the input of the actual input. OT is the output. So if we move to the end where we have the activation functions and the output gate of using sigma T, we come to this. So we have different weights. So the W is weight of the actual variable. You have different variables. So we're using here commodities, agriculture, trying to understand the relationship between them. So the W is the weight of the input within the model. The XT is the training date, and then we do the beta at the end. If there is something that is not significant, we completely forget it. The one on the right is the artificial intelligence one. The one on the left is the normal statistical technique one. I'll skip this. I will not look into this out of linearity and non-linearity. I'll move forward. Data, my data, so on and so forth. Now this is my modeling. This is how I modeled this. So RV is realized volatility, the changes within the model. I can understand that, it's easy. The sum of the month, and then the second one is the realized volatility for the week. 1/21 is the scaling, you scale the number, and you move on to the 5 days, the sum of the 5 days, and then you square root the return. So it removes biases of minuses. And then you go into the coefficient of betas, you go into the coefficient of betas, and you divide them into T, the day, M being the monthly data, W being the weekly data, RV is, of course, the realized volatility of the input of data numbers in 5 different commodities markets. And at the end, where you see Y, the interception of Y, RV, oil, that is the actual conceptualization of volatility. If the variance or changes in one market, how does that go into another market? If something happened in one country, how does that diffuse into another country? If COVID happened 100 years ago, it would have been less deadly than it was. So now I believe that instead of predicting uncertainty, I believe understanding volatility, spillovers within market construction and how it affects different markets is the way forward. But I'll go, there are 2 types of volatility spillovers. There's unidirectional and bidirectional. The green and red illustrates that there was unidirectional and not bidirectional, and not unidirectional, which means one parameter affects the other parameter without the same back. So I'm getting affected by the oil market, but changes with my market, the commodities market, if it was wheat, corn, whatever it was, does not affect the oil market. That is very important for any investment company, for any country, for any type of investment firms where you understand risk, if it was from one area to a contagious of another area. We have the models, how they were done in coding, the least squared, ordinary least squared models. I'll go through the results in one slide at the end. So I will not share, I'll move forward to the conclusion. The contribution is that artificial intelligence did not perform like we thought it was performing. The general statistical technique model did better in understanding volatility spillover. Why? Becoming an academic, the why question is the number one thing. Why did that happen? It is due to complicit, non-linear data points. So due to the data points, there was no significance in the level of correlation because of the artificial intelligence needs complexity within the data points. So the contribution is, it's not always there. We embrace change. Change brings fear, but we don't fear it. We embrace it. Any adoption of change, new change is fearful, but we should embrace it. And there should be a set of policies and regulations that instruct how artificial intelligence is being used. So I recommend here that all professionals and academics in the field of commodities, they look into the statistical techniques of econometric models and the state space models of using spillover volatility and not going towards LSTM, which is long short-term memory. The contradiction. This is the last thing I'll do, and then I think that will be it. The contradiction. 3 days ago, I think it's the 8th of November, my paper got accepted that says artificial intelligence is the future. And today I say artificial intelligence got outperformed by an econometric model done by Corsi in 2009 in the Journal of Financial Econometrics. The LSTM model also has 136,000 citations. So I have a paper published in Scopus Q1 just 3 days ago, maybe it will be published in 3 months, accepted on Saturday, that says that we should use in understanding financial data with how much data we have in complexity, that we should use artificial intelligence. There were 31 mathematical models there, backward propagations, deep neural networks, theta and statistical techniques. So we should use that. Future research, we do bidirectional, low directional references, motivational, the code, and thank you, and that's it.